Hello everyone. In this class we will learn about operator overloading. Previously we have learnt about function overloading, in which we will write multiple function definitions with same function name but different set of input parameters. Now based on what input values we are giving, the function different function gets executed, and accordingly different type of output we can expect. Similarly here, operator overloading is required to make the operator recognize the user defined types. Now let us understand this with an example. The compiler is designed such that all the operators can recognize only the basic data types. We have two categories of data types, right? We have char, int, float and double. So all the operators whatever we have designed, say for example we have plus, minus, this multiplication, division, all these arithmetic operators, basically they can work only with these basic data types. So if I add two int variables, it will give an int result. If I add two float variables, it will give a float result. But these variables cannot work with user defined data types like arrays. So suppose I have an array. If I have int a5 and b5, here c5 I will declare, I cannot give c is equal to a plus b. This will work only if they are individual values, but since they are arrays, strings and all are user defined data types. For user defined data types, the operator is not defined, or the compiler does not have definition for this type of addition. That is the reason we write a for loop, right? So we write a for loop. In that loop, we will take from int I equals to 0, I less than 5, I plus plus. I'll write a loop and I'll add every element separately. I'll add ai plus bi, right? So this is how we do, because I cannot add arrays the way I add int variables, because these are user defined data types. Similar to this, classes and objects are also user defined data types. Suppose I create a complex class. I create a class called complex. This is to store complex numbers. Now I will have int real and imaginary parts. Under public section, I'll have different functions. Now if I have to add these complex numbers in the main function, like if I give complex C1, we have already seen constructors in the previous class. So complex numbers constructors we have already written. Let me assume I am giving 4, 5, C2, E3 or 5. So it means it will assign both real and imaginary variables with 5 for the second object. For first object, 4 is assigned to real and 5 is assigned to imaginary. Now if I want to add these two complex numbers, the first two complex numbers represent 4 plus 5i. The second complex number represents 5 plus 5i. Now if I want to add these two and get 9 plus 10i, I cannot write C3 equals to C1 plus C2. This way I cannot write, because plus operator cannot work on class objects, because class objects are something that we have defined. In the compiler, there is no definition for complex. Therefore, the plus operator will not know which variables to add correspondingly. So we will write an additional definition for operators, that is called as operator overloading. So plus these operators, not just this, we can overload many operators. We will see all the programs one by one. So these operators can work only with basic data types by default. Now if we want to use these operators the same way as we use with our normal int and float variables, then we will have to overload them. What is overloading? Giving additional meanings for existing operators. Now let us see how to do this. So what is operator overloading? It is providing additional definition or making additional definition for existing operators. Additional definition for existing operators. So what is this additional definition, or what does this additional definition do? Because of this additional definition, now these operators can work with, operators can be used with user defined variables, with user defined objects, I'll write. Objects of user defined data type is called as user defined objects. So in the same way we give c equals to a plus b, the same way we add two integer values to float values, similarly we can add two complex numbers, we can add two fractions, we can add two strings, all such additional meanings we can give for existing operator. Now let us see how to do this. So this can be done as part of the class definition, or we can also do it using friend functions. So we can overload operator using member functions. We can also overload operator using friend function. The way we use the program or the way we write the instruction is same in both, but how we define the function varies. Now we'll see the first method using member function, how to overload an operator. So as we have seen in our previous program, we have considered a complex class. We have taken two variables here, real and imaginary, and I will write under public section, I will write a complex constructor. What is a constructor? It is a special member function with the same name as that of the class and no return type. It is used to initialize variables belonging to the object. So here both real and imaginary I will initialize using this x because it is single variable constructor. Then I'll write two variables. So here I am writing overloaded constructors, int x and int y. First variable, first value I'll store in x and second value is initialized to imaginary. So two constructor functions I have written. Now I will write operator overloading function. For writing operator overloading function, we should use operator keyword. Operator keyword. Which operator I am overloading? Here I will overload plus operator to add two complex numbers. I will write plus here. And always for overloading binary operator, it requires two operands, right? So if it is a binary operator plus, it requires two operands. This is the first operand, this is the second operand, right? For two input values, here we will write only one parameter. We will write only one parameter, okay? Complex ampersand. We write one complex object and it returns a complex value as a return type. Return type is of the same class type. Name of the function itself is operator. Which operator we are overloading we have to write, and then inside the bracket we have to write name of the class itself because I am passing one of the variables as a parameter here. I have to pass an object reference here. I'll write one display function for the complex number. So this is my class definition. Now I will have to write this function definition, right? And this is the member function. Okay, since it is member function, when I define it outside the class, I have to mention the scope resolution operator as well. Return type of the function is complex class object. Scope of the function is class name and the scope resolution operator. Name of the function is operator. Which operator we are overloading? Plus. Now here it will take one object parameter. C1 I will take. Now inside this I have to create a complex object for storing the result. I will take it as res. This is for storing the result. Now in this result there is one real part and there is one imaginary part, right? For this I will add, since this is a member function, one operator is required to call this. Since this is a member function and when I write, suppose if I write C3 equals to C1 plus C2, then C2, C1, that is the first object. This is the object, calling object. This is the calling object. This is the object calling this function. Okay. So inside this function, if I mention just real and imaginary, it belongs to C1. C2 is a parameter. The second one, whatever you are giving here, this is considered as an input parameter. So whatever I write as C1.real and C1.imaginary, these belongs to the second parameter. Hope it is clear. Understand this clearly. I am overloading plus operator so that it can recognize class objects and perform addition the same way it does for normal variables. For this, compiler cannot do by itself. We have to provide additional meanings. So I have provided additional meaning by overloading plus operator. Here, since it belongs to a class, since it is a member function, it needs an object to call the function. So first parameter here, C1 is considered as the calling object and this C2 is going to be the input parameter. So inside this function, if I mention only real and imaginary without any object name and dot operator, it belongs to the calling object. So this real and imaginary belongs to the calling object. And the second operand that I have given is considered as the parameter. So this C2 is passed here as parameter. By default, this is how compiler understands. The C2 is passed as the parameter. So the real and imaginary belonging to this C2 is actually this C1.real and C1.imaginary. Using these two real and imaginary parts, I am doing addition. I am storing it in a result object and we will return this result object. When I return this result object, that is stored in C3. Now when I write C3.display, it is going to display contents of its real and imaginary private variables. So to write display function, again I am defining it outside the class, write return type, then mention scope resolution operator, complex class and scope resolution operator, name of the function. Here you write your cout statement for displaying the complex number, I think which we have already written. Now in the main function, we will create complex objects. I'll create object C1, I'll pass values 4 and 5. I'll create object C2, I'll pass values 3 and 8. And I'll create an object C3. Now when I give C3 is equal to C1 plus C2, it is going to add these two real numbers and imaginary numbers correspondingly, and that will be stored in C3. When I give C3.display, it will display the output. So this is how we write operator overloading function, so that we can write the instructions the same way as we write for other variables. So what is the procedure? Inside the class, you have to define a function. Name of the function is operator. Mention the operator which you are supposed to overload. And then so for binary operator, two operands are required. First one is the calling object, second one is the input parameter. So you have to write one parameter only here, and this is the return type. We're defining it outside. Here this is return type, name of the function and operator, parameter. This is scope resolution operator. This is the first method. The second method is using friend functions. When you are using friend function and doing this, the way you execute it is same. Here in this main function, you are going to use it in the same way. For friend function also, for member function based operator overloading also, the way you use is same, but the way you define will vary. Okay, so what all changes are required, I'll write only that here. Now since it is a friend function, I have to mention friend keyword here before the return type, and since object is not required for calling this, it requires two operands. So complex ampersand, two operands are required. C1 is the first one, this C2 is passed here. So there is no object required. This is not calling object. Since operator function does not belong to the class, this is not the calling object. Both are considered as parameters only. So this is the changes required for binary operator. two input variables are required. For unary operator, we require one input variable, same as the number of operands required for this operator. Friend keyword is required here. Both these are taken as parameters. Okay. Now we are defining it outside the class, right? So when we define it outside the class, we need not give this friend here. But scope resolution operator is not required. Scope resolution operator is not required. We give the return type. After return type, I directly give the name of the function, the operator. Both the operands I am going to give it here. Complex ampersand C1, complex ampersand C2. So whatever values have been passed, this first one gets copied onto this second one gets copied onto this. Now here I have created a new complex object. Here I'll take C1.real, C2.real, C1.imaginary, C2.imaginary. So this is the only change required if you are defining an operator overloading function using friend functions. So have to declare it inside the class, define it outside. And since you are declaring inside the class, here since an object is not required, both the objects are considered as parameters, so you need an extra parameter here. And when you are defining it outside the class, scope resolution operator is not required. Two parameters you are taking, and inside the function definition you will have C1 and C2. Both objects are used for accessing the private members. Using it here is same, whether you have overloaded operator overloading function, whether you have done it using the friend function or the member function, it's going to be same. Now let us see this in compiler. Now here I am creating a new file. It's called operator overload 1.cpp. This is for overloading plus operator. I'll write hash include iostream, then using namespace std, standard namespace. Now I'll first create the complex class. We have already created complex class, you can use that also. We have int real and imaginary. Under public section, I will write two constructor functions, one with one variable and one with two variables. So I'll give real equals to x and imaginary equals to x. That is one constructor function when you have only one parameter given. Next it is int x and int y, two parameters given. Here we will use x for real and y for imaginary. Now two complex classes constructors are created. Now I will create one function for display. And I'll define it outside the class, void, that is return type. Now scope resolution operator is given and then name of the function. We will display cout, the real part, plus imaginary part I. This is going to display the complex number. Now I am writing the main function. In the main function, I'll create two complex objects, one with one parameter, C1 with one parameter. I'll create C2 with two parameters 3, 4, and I'll create C3. Now C1 and C2 are initialized using the constructor functions. Now I'll give C1.display and C2.display to display both the complex numbers. Next I want to add these two. I'll give C1 plus C2 and then I'll give C3 dot display. Now if you observe, I wanted to add these two complex numbers and I have given C3 equals to C1 plus C2. But this will not work because plus operator cannot work with user defined objects. We will also create one default constructor. If we don't define constructor, then compiler will give the default constructor, but since we have defined constructors, we need to give default constructor as well. So default constructor will assign both real and imaginary to 0. Now I'll save this program. It should give me an error saying that plus operator is cannot perform the operation for user defined data type. Okay, so we have compiled and it is showing an error at this line number 36. We'll see what is the error. See, here it says complex is not derived from const standard reverse iterator. Okay, something is there as an error. No target. Okay, so there is some error. We cannot this is not recognized. This is not a proper instruction. It's not recognized. That's why it's giving as an error, because this instruction cannot be performed. Now we will give us additional meaning for this. So what we shall do is, I'll define a function here. First I'll show how to do it using member function. Return type, name of the function is operator, plus operator. Now one input parameter only, complex reference. Okay, now we will define this after this display function. I'll write definition for this. Return type, I need to mention scope resolution operator, then operator keyword and the operator to be overloaded. Now within bracket I'll give complex ampersand C1. This is the parameter. Here I will create another object for storing result. Res dot real is equal to just real. This belongs to the first object that is passed, and then C1 dot real. Res dot imaginary is equal to imaginary plus C1 dot imaginary. Now we will return res object. Now this value is returned to this C3. So now when I give C1 plus C2, earlier it showed an error, but now it doesn't show error because I have defined a function which agrees this complex numbers as the parameters, and the result is calculated and result is stored. That is returned, and the returned result is stored in C3. Now let us execute this program. See here, we have got C1 is 5, so both real and imaginary is initialized using 5 only. So 5 plus 5i is displayed, and then 3 plus 4i is displayed. Then I am displaying the sum, which is 8 plus 9i. Now this is how we overload plus operator, any operator. The procedure is same. This is using member functions. Next is, we will see the changes whatever I have told. The same changes I'll apply here, and we'll see how to do the same thing using friend functions. So for friend function, we have to declare it as friend here. So I'll give a friend keyword here. Here, as I told you, you will need two parameters because it does not consider any object as calling object. We don't use an object to call this. Therefore, both the values, both the complex numbers are considered here as parameters. Similarly, just like this function prototype, we have a difference in function definition as well. This is return type. Scope resolution operator is not required as it does not belong. Defining scope is not required as it does not belong to any particular class. Now here I have C1. I'll write complex ampersand C2. We are passing the references of the objects. So here I have created an object for storing the result. I will add C1.real and C2.real. That is real parts of both the objects. So similarly, I'll take C1.imaginary and C2.imaginary, and returning result is same. See, only these changes are required. Before return type, mention friend keyword, and here in the parameters write one extra parameter, and while defining, no need of defining the scope, and again here extra parameter is required, and use these parameter to access the private members of those variables. using the function, using the instruction plus operator, using it is same. Now this one will also give the same result as the previous. So I have saved the program. Now we will execute it. See, we got the same result as previous one. So whether we overload an operator using a member function or a friend function, the way we use it is the same. Only change is how we define it. Okay, based on your convenience or based on what is asked in the exams or placements, you can write that. But when you are actually implementing, it is left to you. You can decide how you want to implement this. This is about operator overloading. Here we have seen example of plus operator overloading, addition operator. We can, the same way we can write for multiplication, subtraction and all that. I will share the program in Telegram channel which has overloading of subtraction operator, multiplication operator and modulus. All these we will overload and we'll see what is the changes required, and overall procedure is this only. If you have found this class useful, then you can like this video and share it among your classmates, and please provide your feedbacks and suggestions in the comment box below, and don't forget to join the Telegram channel in which you have all these programs and notes present already in the Telegram channel. See you in the next video. Bye bye.